Solving exponential equations. Here is the first one. You have 2 to the x power equals 2 to the 3x minus 4 power. You have to solve for x. This is the easiest one you will come up with. If your bases, which in this case are the 2's, are the exact same, then you set the exponents equal to each other. X would have to equal 3x minus 4. Then just solve for x. X minus 3x equals a negative 4. That would be negative 2x equals negative 4. And clearly x would have to be 2. Three to the 2x minus 1 power equals 3. Again, you have the same base. So the exponents would have to be equal. The most common mistake on this problem is that since there is no exponent there, you write it as 0. That is not right. What is the exponent that is missing? 1. 3 to the first power is just 3. Your bases are the same, so you can set 2x minus 1 equal to 1. Move the minus 1 over, make it plus, simplify, and then divide. X is 1. We have 4 to the 3x minus 5 power. And it is equal to 4 to the 8 minus x power. Your bases are the same. Therefore, you set the exponents equal. 3x minus 5 equals 8 minus x. And then solve for x. Move your minus x to the left, change the operation, and the minus 5 to the right, change the operation. You get 4x equals 13. At this point, some of you will stop and put a star beside the problem when you turn it in for the test and claim that it is not doable. Why is that? Comes out to a decimal or a fraction, and we all know that fractions and decimals are not possible in Algebra 2. Is that right? No, it is not right. X equals 13 over 4. Mixed number, decimal, whatever. Improper fraction, mixed number, if you did this as a mixed number, it's 3 1/4. So whatever is equivalent. If I tell you to express your answer in a certain way, you must do that. If not, whatever is equivalent. The only thing you cannot do is turn in things that are like 22 over 11, 26 over 4. Why can't you turn those in? They reduce, and if you don't reduce them, then you're going to miss some points. You have 5 to the x plus 1 power equals 25. The bases are not the same. You have a 5 and a 25. You're going to have to change one of these bases. Change this one. This would stay the same. But we need to express 25 as a base of 5 raised to some power. How can I express 25 as 5 to some power? 5 squared. Now you have the same base. You can set the exponents equal to one another. X plus 1 equals 2. Move the 1 to the right, change the sign, and come up with x equals 1. We have x, or not x, but we have 1/3 to the x minus 2 power, and then we have 9 to the 3x power. We have to figure out how we're going to change the base of either of these, or both, in order to come up with something that I can work with. Okay, so if we want to change that 1/3 into something that has a base of 3, then, and while it's still being equivalent, then we could do this. Our first step could be, for that 1/3, instead of having 1/3, how did we get to that 1/3 to begin with if we started with a 3? If we started with a 3, what did we have as an exponent that made that a 1/3? What sign of the exponent made it flip? We will review. 5 to the -2 power is 1/25. 4 to the -1 is 1/4. 2 to the -3 power would be 1/8. You see what I'm doing? Okay, so if we go back over here, that 1/3, 3 to the -3rd power. Negative first power, yes. So we would have 3 to the -1st power. And don't forget the x minus 2 out there as well. Okay, but does this help us out? I need a base of 9. What do we do to these exponents? Whenever you have, by rule, whenever you have a power raised to another power, what do you do to those exponents? You have 4 choices. What is it? You multiply them together. So I could do 3 to the power of -1 times x minus 2. What is -1 times x minus 2? What's -1 times x? Negative x. And what's -1 times a -2? Plus 2. Okay, so we've made it this far, but we still need a base of 9, or we could need a base of 3, whichever. You can change one, you can change the other. How about the problem we did that had a 25 in it? What did we do to it? Yeah, we made 25 into 5 squared. What can we do to 9? We could do 3 squared. So on the left it's 3 to the -x plus 2 power. And on the right we have 3 squared to the 3x power. What did we do to exponents that are separated by a parenthesis? We multiply them. So on the left we have 3 to the -x plus 2. And then equals 3 to what power? Yeah, 3 to the 6x power. Okay, we have the same base in each situation. So that means we can set -x plus 2 equal to 6x. Strange looking 6. Alright, we're going to solve this. And I am going to move the 6x to the left, change the operation, and the 2 to the right, change the operation. So that's -7x equals -2. The answer is going to be -2 over -7, and can I quit there? No. What is the answer? 2 over 7. (125) to the 3 minus 2x power equals 5 to the x minus 1 power. How can I rewrite 125 as a base of 5 raised to some power? 5 to the first is what? 5. 5 to the second is what? 25. 5 to the third is 125. So I can write 5 to the third in place of 125. On this side, we stay the same. What must I do with 3 and 3 minus 2x? Multiply them. What do I get? 9 minus 6x. Are the bases the same now? Yes, so I can set 9 minus 6x equal to x minus 1. And solve that very simple equation. Negative 6x minus x equals negative 1 minus 9. So that's negative 7x equals negative 10. Divide negative 10 by negative 7. And we come up with an answer of 10 over 7. Or 1 3/7. For this problem, we have 1/4 to the x power equals 8 to the x minus 1 power. Well, the first thing we're going to need to do is to get rid of this 1/4. We need to convert it to something that we can use as an integer. And to do that, you would make it 4 to the negative 1 power, and then to the x power. Now you're presented with a dilemma. 4 to what integer power is 8? There isn't one. And 8 to some integer root, the integer root of 8, you're not going to find one that makes it a 4. But there's nothing that says there isn't another number that you could write and change the base to. What number can you raise to an integer power in one case and get a 4, but in another case raise it to a different integer power and get an 8? 2. 2 is right. So we will go here and simplify first. Negative 1 times x is going to give me negative x. But now we can rewrite that 4 as a base of 2. 2 to the second power is 4. Over here with the 8, 2 to what power is 8? 3. So 2 to the third power we will write in place of 8 and keep the x minus 1. Okay, so now we multiply these exponents together and multiply these exponents together to come up with 2 to the negative 2x power equals 2 to the 3x minus 3 power. And since we have the same base, we can set negative 2x equal to 3x minus 3. Solve that very simple equation by doing negative 2x minus 3x equals negative 3. That's a negative 5x equals negative 3. Divide negative 3 by negative 5. That is not your answer because it is not simplified. You come up with x equals 3 over 5. This next problem is something that you have to draw upon that we just recently did last week. We have 4 to the 2x power equals 16 times the cube root of 4. Remember from last week and the week before that you can change a root into a base with a fractional exponent. Just like when you type it in your calculator to solve or evaluate this. You can change it. So we'll keep 4 to the 2x the same. We'll keep 16 to the same. And but for the cube root of 4, remember that's the same as 4 to the third power. So we have 4 to the 2x equals 16 times 4 to the third. This problem would be doable right now if it wasn't for what number? 16. We can change that 16 to a base of 4. What is 16 with a base of 4? 4 squared, yes. So we will keep this side the same. And 16 is the same as 4 squared. But now we have two bases on the right-hand side instead of just one. Whenever you have two bases that are the same and you're multiplying them together, what do you do with the exponents? You add them together. So we will keep this side the same. And when you have 2 plus a third, it is 2 1/3. So now we have the bases completely the same. If they're completely the same, then we can set 2x equal to 2 1/3. That is the same thing as 2x equals 7/3. And when I divide by 2, it is the same thing as multiplying by 1/2. So I get 7/6 for my answer. Did anybody come up with 7/6?